Hello dear student, today I will discuss about design of bearing bolts. Before discuss it, I will discuss about assumption of the design. There are many assumptions we'll consider. First is friction between the plates is negligible. Second, shear is uniform over the cross section of the bolt. And third, distribution of stress on the plate between bolt hole in is uniform. Clear? Now fourth, bolt in a group subjected to direct loads share the load equally. Clear? Now fifth, bending stress developed in the bolts is neglected. Right? Now design of bearing bolts. The failure of a joint can be in bolt or plate. These two things are very important. Okay. The strength of a joint will be minimum of strength of joint based on strength of bolt in a joint and the net tensile strength of the plate. Okay. Since the bolt can be fail either shear or in bearing, that's why the strength of bolt should be taken as the minimum strength of bolt in shear and bearing. Right? Now, shearing strength of bearing type of bolt. The resistance of bolt to shear is called nominal capacity of bolt in shear and it is denoted by V and SB. Okay, it depends on ultimate tensile strength of bolt which is denoted by FUB. Okay, so nominal capacity of bolt in shear is equal to, which is denoted by V and SB. V and SB is equal to FUB divided by root 3 into NN ANB NS ASB. In this formula, you can see the clause number 10.3.3, where FUB ultimate tensile strength of bolt, NN is the number of shear plane with threaded intercepting the shear plane, NS is the number of shear plane without threads intercepting the shear plane, and ASB is the nominal plane sunk area of the bolt. Right? And ASB is the net tensile area at thread, may be taken as area corresponding to root diameter at the thread. Right? For the bolts in single shear, either N or NS is on and other 0. Clear? For bolt in double shear, sum of N and NS is 2. So you can see NN is equal to 1 or NS is equal to 1. So in double shear, NS and NN, NS plus NN equal to 2. Clear? Then it is always remember it, VSB is less than equal to VDSB. Okay, what is VSB? VSB is the factor shear force. Okay, and VDSB is design shear strength of bolt. Right? Now, design shear strength of bolt is which is denoted by VDSB is given by VDSB is equal to VNSB. VNSB is nominal shear capacity, okay, divided by gamma MB. Gamma MB, what? Gamma MB is the partial safety factor for the material of bolt, okay, which is 1.25 as per table number 5 IS 800 2007. Clear? Now, finally, design shear strength of bolt VDSB is equal to FUB by root 3 into gamma MB, okay, into NN ANB plus NS ASB. Clear? Reduction factor for nominal shear capacity of bolt. In long joint, the bolt further away from the center of joint will carry more load than the bolt located close to the center. Clear? Therefore, for joint having more than 2 bolts on the either side of the connection with distance between first and last bolt exceeding 15D in the direction of load, the shear capacity of the joint shall be reduced by factor beta Lg given by clause number 10.3.3.1 IS 800 2007. So, beta Lg is equal to 1.07 minus Lj divided by 200D, but 0.75 less than equal to beta Lg less than equal to 1, right? Where D is the nominal diameter of bolt, Lj is the length of joint, which is equals to distance between first and last row of bolts measured in the direction of load, right? Now similarly, if the grip length exceeds 5 times the nominal diameter, the strength is reduced by a factor beta Lg as per clause number 3.3.2. Strength is also reduced thickness of packing plate exceed 6 mm by factor beta Pk as per clause number 10.3.3.3. So the design shear capacity of bolt for long joint, long grip length and with packing plates, if provided, will be modified as below. So finally, VDSB is equal to FUB divided by root 3 gamma MB into NN ANB plus NS ASB into beta Lj into beta Lg into beta Pk. Clear? Now, bearing strength of bolt. If the connected plates are made of high strength steel, then failure of bolt can take place by bearing of plate on the bolt. If the plate material is weaker than the bolt material, then failure will occur by bearing of the bolt on the plate and the hole will elongated, right? The design bearing strength of bolt on any plate VDSB as governed by bearing is given by VDP VDPV is equal to VNPB divided by gamma MB, where VNPB is the nominal bearing strength of bolt and gamma MB is partial safety factor of bolt, which is 1.25. So the nominal bearing strength of bolt is given by VNPB is equal to 2.5 kb dt into Fu. Okay, where kb is smaller of EY 3D0, comma PY 3D0 minus 0.25, comma FUB by FU and 1, which is smaller in this value. Okay, EP is the end and pitch distance of the fastener along bearing direction. D0 is the diameter of hole. FUV and FU is the ultimate tensile stress of the bolt and ultimate tensile strength of the plate respectively. This is the nominal diameter of the bolt. Clear? T is the summation of thickness of the connected plate experiencing bearing stress in the same direction. In case bolts are countersunk, then it should be taken as the thickness of plate minus half of the depth of counter sinking. The design strength of bolt in bearing is given by VDPB is equal to 2.5 kb dt Fu by gamma MB. Right? In case of bar joint, thickness of cover plate should not be less than 5 by 8 into T, where T is the thickness of the main plate. Right? Now I will discuss about tensile strength of bolt. When bolts are subjected to tensile load, the bolts are designed as the tension member. As per clause 10.3.5, a bolt subjected to a factor tension force, which is equal to TB, shall satisfy TB less than equal to TDB. Clear? So, factor tensile force less than equal to design tension capacity of bolt. Okay, where TB is the design tension capacity of the bolt. Finally, TB is equal to TNB by gamma MB, where TNB is the nominal tensile capacity of bolt and gamma MB is the partial safety factor of bolt, which is 1.25. Nominal tensile capacity of bolt TNB is calculated as TNB is equal to 0.9 FUB AN less than FYB ASB into gamma MB by gamma M0, where FUV is the ultimate tensile strength of bolt, FYB is the yield stress of the bolt, and AN is the net tensile stress of area of bolt. ASB is the sunk area of bolt. Okay. Now, tension capacity of the plate. The plate in a joint may fail in tension through weakest section due to its holes. The holes may be arranged the longitudinal direction of the plate, so that number of holes is equal to all row across width, or staggered, so that the number of hole across the width reduced. Okay. In the first case, the plate will fail across the weakest section. Where is the second case? The failure along zigzag pattern, the design tension capacity TDN of the plate exposed as TDN is equal to 0.9 divided by 0.9 into Fu by gamma m1 into An as per clause number 6.3.1 IS 800 2007, where Fu is the ultimate stress of material, An is the net effective area of the plate, gamma m1 is equal to partial safety factor for failure ultimate stress, which is 1.25. Now, the net effective area of a plate An depend on arrange of bolts hole. If hole are not staggered, then An is equal to B minus N into dH into T. Okay. For staggered holes, An is equal to B minus N into dH plus summation of m I0 I is equal to 1 pi square divided by 4gi into T, where B is the width of plate, N is the number of hole, dH is the diameter of hole, pi is the staggered pitch, and gi is the gauge distance. Now I will discuss about efficiency of the joint. Efficiency of the bolt joint, which is denoted by eta. Okay. Efficiency of the bolt joint is equal to strength of bolt joint per pitch length divided by strength of solid plate per pitch length into 100. Its unit is percentage. Okay. Now, combined shear and tension. A bolt required to resist both shear and tension at the same time shall satisfy VSB divided by VDSB whole square plus TB by TDB whole square less than equal to 1, where VSB is the factored shear force on bolt and VDSB is equal to design shear capacity, TB is the factor tensile force on bolt, and TDB is the design tension capacity. Okay, you can see the picture of a chain hole in raw. Okay, this is called longitudinal hair to hair distance is called P, pitch distance, and hair to hair is called gauge distance, and hair to hair is called edge distance. Okay, in this case An is equal to B minus N into D into T. Clear? For staggered, this is the picture of staggered. In this case, hair to hair distance is pitch distance. Okay, and hair to hair distance is called gauge distance, and this distance is called path failure. Okay, thanks for watching this video. If you have any query, please comment on the comment section, and next video I will discuss about its problem. Okay.